Hello, my name is Luc Paquette. I'm an assistant professor in the College of Education at the University of Illinois at Urbana-Champaign, and I'm going to be presenting our work called Who's Learning? Using Demographics in EDM Research. This is work I've been doing with a group of colleagues both at the University of Illinois and at the University of Pennsylvania. To get things started, I want to give a little bit of background motivation for this work. As you are probably very aware, there is a growing use of machine learning for the data-driven study of social issues and for data-driven decisions around those social issues. And this includes education, and this is something that as a community, the educational data mining, we care about very much. However, it also requires us to re-examine the often implicit assumptions that data-driven models are neutral and free of biases. There's growing examples of how applications of machine learning may be biased and may perpetuate inequalities. I'm sure you've probably encountered in your research, in papers, or in the news, articles that talk about some of those issues. So for example, gender stereotypes that might come up in natural language processing, or racial biases related to facial recognition or in the social justice system. There's many books that you might have heard about that are addressing this topic. You might even have read those books. But looking at all of this really, for us, brought the question, which is how does the field of EDM approach issues of fairness and biases? So in this work, our goal was not to quantify existing biases in EDM research, but rather to provide kind of a broad picture of current efforts related to issues of biases and fairness in EDM research. We specifically focused on the reporting and use of demographic information, which is only one aspect of fairness and biases, but this is something we thought was very important to do. And so to do this, we conducted a survey of current practices in EDM publications. So we looked at all of the EDM publications in any EDM venues, and that included both journal and conferences from the year 2015 to 2019. So in total, we looked at 385 papers that were either journal papers, long conference papers, or short conference papers. We did not include conference posters because those are usually early work in progress that have limited length and might not cover the full scope of the project. So when we looked at the different types of publications and the different years of publication, you'll see that there's very different number of publications across those. I'm not going to go into the details, but if you're interested, those numbers are also in the paper. So what we were interested in was to look at those publications to try to see whether demographic information was relevant to the research that was in this paper. And also, if that was the case, what kind of categories of demographic information was reported and how was that information used? And so in terms of applicability, we considered that demographic information was applicable if the paper used data that can show demographic-based differences. And so a very big example for us would be a paper that uses student data. And so papers, for example, that try to predict at-risk students or that uses knowledge discovery to infer categories of student behavior would be applicable. Demographic information would be considered not applicable if the paper made more of a methodological contribution or analyzed data with no demographic variation. So for example, a paper that would compare the properties of different knowledge tracing algorithm, or a paper that would try to automatically label learning objectives in text documents. So when we looked at those, we also looked at the categories of reported demographic information. And so we chose those based on some of the categories used by the US Department of Education. And so they included age, educational level, gender, race or ethnicity, socioeconomic status, and also geographic location. And then finally, we looked at how was that information used. And so we divided it in three usage categories that included investigated, feature and model, and testing and validation. We also coded for papers that reported demographic information but did not use it, or papers that did not report any demographic information. So when we look at those categories, the first one, investigated, is related to the use of EDM to explicitly investigate and answer at least one question related to the experience of different demographics. One example would be a paper that studied the differences in online course activity profiles based on country of the student. Then we also looked at papers that might use demographic information as feature in the model. So this is cases where the paper used at least one demographic variable as an input feature to create a model or as part of model training. One example would be a paper that uses gender, ethnicity, and parent income as potential predictors of student enrollment in college. And then finally, we also looked at testing and validation. That's when a paper would use the different values of the demographic variables to define different testing set. And so one example would be comparing the accuracy of a predictive model based on different genders or on different races. For the full coding process, we looked at each paper individually, and then we first started by making a judgment about whether demographic information was applicable for that paper. Then we made a list of all the demographic categories that were reported, and finally we looked at whether the paper used those demographic information across one of the three categories that we've identified. One thing that's important to note is that it's possible for a publication to use the demographic information in more than one way. So for example, a paper could both investigate a question related to demographic and also use demographic variables as input features in their model. The coding itself, especially for the categories of reported demographic variables, was generous in the sense that we wanted to measure an upper boundary for the reporting frequency. And so that means that a paper was considered as reporting the variable, even if it only reported aggregated data. Similarly, proxy variables were counted towards the coded category. So for example, free and reduced lunch was counted as a proxy for socioeconomic status. Two different coders were involved in the process of coding those 385 papers. Inter-rater agreement was computed over a set of 75 papers that were semi-randomly selected to make sure that there were multiple examples of the rare codes in our coding scheme. And then Cohen's kappa was used to measure the agreement. And those ranged from 0.721 to 0.946. So when we look at those values of kappa for the different codes we add, we can see that for the demographic categories, race, SES, and geographical locations were the one with the lowest kappa. They were also the ones that were the most likely to be reported using proxy variables. And then in terms of the usage, we can see that investigated was the one with the lowest kappa. It's also the one that has the most different ways that it can manifest itself. Now, once we've done the coding, then we could start looking at kind of what the data was telling us. So we started by looking at the percentage of papers for which demographic information was considered applicable. So what we can see is that for a majority of paper, we considered that demographic information was applicable for 75% of paper. And so those are the paper that we used in our further analyses. Then we looked at the frequency of report for each demographic information category. So the first thing we can see here is that there is a general recognition of the importance of the demographic in EDM research. About 72% of publications reported at least one demographic variable. However, the ones that were the most commonly reported were education level of participant and geographical location. And those, while they're important information when we're considering biases and who participates in EDM research, they're not necessarily sufficient for describing the student's social cultural background in more detail. And then when we look at variables that are more likely to be related to historical problems with educational equity, those were less frequently reported. Gender was reported somewhat frequently, 25% of the time, but race was only reported 9% of the time, and SES was only reported 5% of the time. So one of the trends we can see here is that the more sensitive the data is and the more difficult the information is to obtain, the less likely it is to be reported, which is probably not surprising. And so one example is education level and geographic locations are the two most reported demographic categories, but they're also usually related more to the context of the study compared to the participants themselves. So, for example, a paper might say that the study took place with 9th graders from a small suburban school district in Midwestern USA. So it informs us about education level and geographic location, but it doesn't really give detail about individual students. And so when we look at how frequently that information is actually used in the analyses, we can see that only 15% of paper actually made use of that information in any way. The most common way was to use it for model building. So 8% of the paper used demographic variables as input features. And then 7% of publications directly investigated research questions related to demographics. And then finally, only 1% of publications use demographic variables to assess model biases through testing and validation. And so when we look at those results, I think one thing that's important to consider is that while it is not expected that all of the EDM publications will specifically investigate issues related to fairness and biases, we do believe there is room for these issues to be considered in more publication. And especially in terms of testing and validation, there was only 1% of publication that use demographic information in that way. And so perhaps one way, not the only way, but one way that is actionable would be for EDM to use demographic variables more frequently for testing and validation to try to identify if there's any potential biases in the models that we create. Of course, this is not going to be necessarily that easy because it will require a more fairness-aware data collection. We did report that 70% of the surveyed publications had at least one demographic variable in them. However, there was also a tendency to report the easy-to-collect information, and the variables that provided richer social cultural background were more frequently omitted. And so it might be beneficial for EDM researchers to make conscious efforts to collect richer demographic data and also to ensure that the collected data include diverse groups of participants. Like I said, there is going to be a challenge to achieve that. The EDM research, we sometimes use historical data, and that might have been collected without demographic information already. We also sometimes use platforms that don't have the ability to collect demographic information. And also, just because of the sensitive nature of some of the demographic variables, that might require more additional protective measures, which will make data collection and research a little bit more complex. We still believe that this additional effort required to collect the demographic data will have long-term benefits for the EDM community, and this is something we should strive for. So the survey we looked at was related to data up to 2019, but we're in 2020 right now, and we're halfway in 2020, and we have the 2020 EDM research conference. So I was curious to see what is happening this year in terms of fairness in educational data mining. And so one thing that is really interesting is that this year at the conference, we had the first workshop on fairness, accountability, and transparency in educational data, the first time it's associated to the Educational Data Mining Conference. We also have, for the first time, sessions that are specifically on the topic of fairness and ethics. And also, if you look at the preface of the proceedings, you'll see that it reports that 10 papers were associated with the keywords of equity and fairness in EDM. So if you open the proceedings and you look at the titles of some of the paper, you might see some of them that explicitly address biases and fairness in educational data mining. And so I think this is really encouraging to see that this is something that we're already working towards and that we already consider as being important part of our research. There's other machine learning communities that are also working towards development of fairness measures and algorithmic solutions to address biases. We think that the EDM community, especially because of our strong multidisciplinary nature, we're strongly positioned to investigate how those approaches can be applied to educational data and to develop methods that are maybe more adapted to the specific context of educational data. So with that, I would like to thank you for taking the time to listen to this presentation. Thank you.